In this pre-algebra video, we're going to talk about Chapter 1, Lesson 10, Comparing Real Numbers. Our objective is, as the student, I can compare mathematical expressions because I will need it when working with any type of real numbers in various situations. This way you'll always be prepared regardless of how the numbers or the values are presented to you. You'll know how to relate them to each other and be able to do mathematical operations with them. Alright, so pretty much every number we discuss in math for now, all the way up until pretty much Algebra 2, everything is going to be a real number. In Algebra 2, you'll discover some things called imaginary numbers, but those aren't our concern right now. So everything is a real number. So we're going to talk about two types of real numbers. The biggest category are rational numbers. Rational numbers are things that can be represented with a ratio or a fraction. So for example, 2/3 is a rational number, 5 is a rational number because 5 technically can be a fraction if it's 5 over 1, -4 is a rational number because it can be over 1, etc. And 7.6 is a rational number because of what I wrote below it. 7.6 is a terminating decimal, and I wrote the decimals for rational numbers will terminate or repeat. So 7.6 technically can be written as 7 6/10. And sure, you can simplify that, but my point is it can be written as a fraction if it terminates or even if it has a pattern. So 2.6666 down below, that would be 2 2/3. 5.45 with the 4/5 repeating, that's going to be 5 45/99. I know it's a mouthful, but if you were to divide that fraction, 45 divided by 99, you would get 454545. So these are some examples I'm talking about. If the decimals terminate like 0.6 or 0.64, if they stop, and you're not rounding to make them stop, if they stop on their own, it's a rational number, and if they have some kind of repeating pattern, it's a rational number. So the opposite of that is going to be irrational numbers. So irrational numbers are essentially the opposites of all those. Rational numbers cannot be shown with a fraction. Long story short, all these things I described that are rational numbers are rational numbers. And if you want to keep it simple as everything else is irrational, that's pretty much how it works. So basically an irrational number will never be a fraction, it won't be a terminating decimal, but it will be a decimal, but here's the difference. An irrational number's decimal goes on forever without a pattern. So I was just making up random numbers just now. So an irrational number will go on forever without a pattern. And it can be positive, negative, it doesn't matter. So without a pattern. Now, you'll see those in decimal form, or sometimes you'll see them as square roots of non-perfect squares. For example, the square root of 5, if you were to do that with your calculator, the square root of 5 is 2.2360679. It keeps going on forever without a pattern. So for that reason, it's going to be irrational. And that's true of any non-perfect square. If you try to take the square root of any non-perfect square, we talked about in a previous video, all of those will be irrational numbers. So things like pi, that's a irrational number because even though we round pi to 3.14, technically it keeps going and going and going. And that's just an approximation that we use. So it's like 3.14, 159, I don't know any more of the digits after that, but they keep going without a pattern. That's what I mean by irrational numbers. So if there is a pattern or it terminates, it's rational. If it's not, it's irrational. So because of that, all the different types of numbers we talk about, they all fall under the umbrella of rational numbers. Well, everything's a real number, but within that category, everything is a rational number. Things like integers, whole numbers, natural numbers, things like that. All those things are going to be rational numbers. Now I'm going to give you a few examples of those. So this is like a graphic organizer of kind of showing you how they all fit together. Everything on this screen is a real number, but of real numbers we have two categories. Rational numbers, which has all the different other types, and then irrational numbers. So we already said some examples of irrational numbers, things like pi, things like the square root of non-perfect squares, like 10 is not a perfect square, so its square root is going to be an irrational decimal. Things like that. Or even decimals that go on forever without a pattern. I'm just making up those digits. Rational numbers, on the other hand, can be represented as fractions. So their decimals, let me do that in blue. Their decimals will have a pattern. So for example, 0.4 with the 4 repeating. It can be a fraction. They can be a terminating decimal such as 0.45. They can be a percentage like 18% because 18% is also known as 18 over 100 because that's the definition of percent. Things like that. And they're welcome to be negative. It doesn't matter. So those are rational numbers. Now integers are positive and negative numbers with, I kind of call them whole numbers. No decimals, no fractions, but they can be positive or negative. Numbers like -7, -4, 8, 9. Now everything we're talking about inside, all these are also rational numbers. And the same thing goes for whole numbers and natural numbers. All of those will also be integers. So whole numbers are going to include things like 0, 1, 2, 3, and 0, 1, 2, 3 are also integers, but they're more specifically they're whole numbers since that's a type. Then we're going to move deeper to natural numbers. Natural numbers are generally counting numbers, not including 0. Things like 1, 2, 3, 4, 5, 6, so they're positive and they go all the way up, but they don't include 0. And by the way, whole numbers do not include negative numbers. The integers are when the negative number category kind of starts, when you're working your way out. So these are the different types of numbers. This graphic organizer can help you keep track of them. So be prepared, you will have questions that will ask you to identify what type of number. They'll say something along the lines of, name all sets of numbers to which each of these numbers belong to. So for example, if you were given the number 9, like you have down here inside of the integer example, you would say 9. It is an integer and it is a rational number. You don't need to mention its real numbers. Everything we're doing is real numbers up until sometime in Algebra 2. But to be specific with 9, you would say it's an integer rational number. Or if we said the number 5, such as we have inside of here in the natural numbers, 5 you would say is a natural number, it's a whole number, it's an integer, and it's a rational number. So you got to kind of list all of them for questions like that to make sure you really understand the different types of numbers. Now we're going to do some examples of comparing these and be able to find ways. Sometimes it's easier to turn everything into a decimal and round enough to where you can see who's bigger or smaller, things like that. That's what we're going to do some examples. So for example, on these examples, your job is to determine whether it is greater than, less than, or equal to when you're doing these. Now, the fastest way I recommend you do all of these, and this is perfectly fine with me, is go ahead and just use your calculator and see what each of these are as a decimal, and you'll need to round just far enough to have enough place values to be able to tell your answer. So for example, you'll type in square root of 18. Square root of 18 is 4.2, but that's not enough information because it keeps going. Remember, it's a non-perfect square. So 4.2426, that is enough information. So 4.242, that's already enough information because this one's 4.20 if you want to put it there. And you'll notice 0.24 is bigger than 0.20. And so for that reason, that one is going to be bigger. So the alligator needs to eat that one. So it's going to be greater than. So this is what I mean by checking. Show as many of the decimal places as you need in order to have enough answers to break the tie if it looks like there is one, like how both these are 4.2 starting off. Now, for the next one, 2.41, that essentially means 2.4141, and the 4 ones keep going. Now we need to figure out what is the square root of 5.8. Square root of 5.8 is 2.408, and it keeps going on, but not in a pattern. It goes on forever. It's an irrational number, but that's enough information. They both start off as 2.4, but that first one has 2.41, and that is going to be bigger than 2.40. So this first one is going to be bigger, so that one also happened to be greater than. They can be less than, they can be equal to, but these two examples just happen to both be greater than. So take a look at the one I drew in the top right. In this example, the instructions would say something along the lines of, order each set of numbers from least to greatest, and then verify your answers by graphing them on a number line. So to confirm, we're going to put our answers on a number line. So I'll go ahead and get that number line, just the template of it drawn out. Okay, so now before we can even compare these, like I said, for all these different types of numbers, in order to compare them, the fastest way is going to be to make them into decimals first. So right below them, I'm going to kind of write what each of them are as decimals, since that's kind of the common ground for most of these. If you type in 5 square root on your basic 4 function calculator, you're going to get 2.236. And if you type in 7 divided by 3 for 7 over 3, you're going to get 2.333, and the 3 will be repeating. So I'll just include a 3 of them. Now, I'm just including enough where I think 3 decimal places will most likely be enough in order to break any kind of ties we might have. Square root of 6 would be 2.449. And then the rest of them already are in decimal form, so I'm just going to drop those down. So now that we kind of have the roughly rounded decimal equivalents of all of our numbers, we are now able to tell who is the smallest, and the smallest is going to be square root of 5. So that's going to be the first one that we're going to put down on there. And it'll be the least one, it'll be one furthest to the left. Now, when making your number line, kind of use your judgment. What increments should you be going by in your number line? If you'll notice, all of our examples, they're all 2 point something. So for that reason, I would say have your number line go from somewhere from 2.1 to 2.7 to where, and have each tick mark being worth 0.1, so there's enough room for you to graph these in between. So I'm going to go ahead and just jot those down. So I was having a little bit of difficulty fitting my numbers, so I just started staggering them so that you could see them all. So 2.1 through 2.7, that's enough for a range to include all of these. Now we're ready to go ahead and graph them. 2.236. Now, that's going to be between 2.2 and 2.3, but it's going to be closer to 2.2 than it is 2.3. I'm going to graph these above the number line, and I recommend doing this anytime you're graphing. It also helps in case you need to make an adjustment. You don't have to erase the whole number line. So a little less than halfway, but between 2 and 3. That's going to be square root of 5. Now, our next smallest one is going to be the 2.333, so that's going to be 7/3. So that's just a little bit more than 2.3. So just a little more. So about right there. So that's where 7/3 is going to be. And now so on and so forth. And go ahead and graph all of these. It'll help you confirm, and then we'll just list them in least to greatest order. So I've graphed all of them, so now we're ready just to write our answer and list them in least to greatest form. So square root of 5, 7/3, square root of 6, 2.5, and 2.55. That's how these are going to look in least to greatest order. So this is what we mean by being able to compare any types of numbers to each other. And of course, as a reminder, if some of these were negative, you still kind of go off of the ones furthest to the left or the least ones. Those are the smallest ones. Okay, so a brief recap and we're going to be all done. So back to the beginning real fast. We were comparing real numbers because we're going to use we're going to compare any kind of real number or mathematical expression. That way, no matter what type of number the problem has, we're going to be able to handle it, be able to address it. We also talked about categorizing the two main categories of real numbers: rational numbers and irrational numbers. Essentially everything is rational that follow those rules, and where it does terminate, or it has a pattern, or it can be a fraction, or all those things mean fraction. So if it's anything else, it's irrational. Some examples are on the right. We did a graphic organizer. We talked about how they kind of fit together with some examples. This slide right here I think would be extremely useful for that reason, because you will have questions where they ask you to identify what type of number, what all sets of numbers does this belong to, questions like that. And then we went through and did a few examples of comparing different types of real numbers. And you'll notice the easiest way to do these, and I don't mind, is using your calculator and turning these into decimal equivalents and just including enough of the decimal place values, enough numbers after the decimal, to be able to clearly see who is bigger, who is smaller, by using what you know about place value. So make sure you have all this written down, make sure you're ready, and we'll take it further in class.